Okay, guys and girls, before we get started, we have a matter of utmost importance, something that we absolutely must address before we commence, lest we don't get this done. So, on my count, can you please say open source? Oh, that is so good. Thank you. Love it. Thank you, everybody. Welcome. Hi, everybody. What is it? Dzień dobry, is that right? Yay! I love Poland. Well, hi. Welcome to my talk. My name is Josh Long. You can tell because it says Josh up there. My email, my Twitter coordinates, all of that's up there, ready for you. How many of you are on Twitter? It's 2015. Twitter? No Twitter? Got my friends, Twitter, it's awesome. So get on there if you can. If you have questions, if you leave this talk more confused than when you entered, feel free to email me. I have my email up there, and Twitter and so on. I am at your service. The code that we're going to be looking at today is more or less available on that URL there. Very importantly, I want you all to first remember that the slides are available online right here. I've made these slides. People always ask me, Josh, I would love the slides. Please, where can I get these slides? These slides are amazing, and they're right there. So please don't hesitate to get them. Also, I want to encourage everyone to, besides answering and asking questions here in the room, I want to encourage everyone to go to qa.devox.pl and throw your questions out there, and I'll be happy to answer them as quickly and expediently as humanly possible. And then finally, of course, I would love it if you voted, because otherwise they won't invite me back, and if they don't invite me back, then I can't have all this amazing food. So there's a reason for you to vote. I need the food. Now, also, I will be giving a talk in the same room after this, and it's sort of the natural follow-on to this. So if you appreciate what we're doing here, you're going to love what we're going to talk about in the next talk after the quickies. A little bit about me. My name is Josh Long. We talked about that already. I'm a Java champion. Yay, Java. I'm a contributor to lots of open source stuff. Spring Boot, not the least of which, of course. Spring Cloud, Spring Integration, Vaadin, the activity BPMN engine, and a few other projects besides. I'm a Java 1 rock star. I'm proud of that. Author of almost five books now, and 3 video trainings. The latest and greatest of my videos and my books concern themselves with building cloud-native applications that live and work well in a modern cloud-based environment, okay? So I care about this stuff a lot. That's what we're going to talk about today is how to build applications that work well in these environments. I work for a company called Pivotal. How many of you have heard of Pivotal? Pivotal. We have a booth. Pivotal's a small startup. We're a small, tiny startup in the Valley in the States. We are the new home of the Spring team. So if you've heard of Spring, how many of you have heard of Spring? Anybody? Okay, Spring is kind of a thing. I like Spring, and I tend to bring the Spring, so rock on. Spring, what about Apache Tomcat? Tomcat, anybody here? No? Yes? Okay. Redis, a distributed data structure server. It's used by some small mom-and-pop shops like Twitter. Anybody here Twitter? Redis? Okay. RabbitMQ, it's a message broker. It's AMQP. It's an open source thing. Anybody? Yeah? All right, right on. Good stuff. So Cloud Foundry, an open source platform as a service. It's a cloud. It's like Google App Engine or Heroku without the lock-in and the crazy prices. Think of it as kind of being a kernel. It's an operating system for the cloud. We make the kernel in cooperation with a giant economy. We have a foundation. And other small startups, just like Pivotal, they have taken that code and they've used it to build their own distributions, if you will, sort of like the Linux kernel and other distributions of Linux. How many of you have heard of IBM? IBM, anybody? IBM. They have a cloud called Bluemix, which is based on Cloud Foundry. How many of you have heard of HP, one of those startups I was mentioning? HP. So they have HP Helion, their entire cloud-based story, again, based on Cloud Foundry. And of course, at Pivotal, we make our own distribution of Cloud Foundry. It's called Pivotal Cloud Foundry. Imagine if Linus Torvalds, besides working on the kernel, also made his own distribution. Wouldn't it be the craziest, coolest thing ever? Of course it would. So that's what ours is It's an awesome distribution of this amazing little platform. Now, we're going to talk about building applications in the cloud. We're going to talk about how to stand something up quickly. The numbers just reverted to 1 hour. Okay, whatever. We should keep in mind as we move forward that building applications today is it's easy enough if you know what you're looking for, and if you're trying to build applications that live and work in the cloud. There are a lot of non-functional requirements, right? So these are the things that keep people from going to production quickly. We at Pivotal believe in Agile. We're very, very big on Agile. And we find that a lot of times the problems, the complexity in getting stuff out the door is, first of all, the integration of components, and second of all, these non-functional requirements, things that stop you at the end of the process, or at least we think they're at the end of the process. Okay, well, that's the end of my slides. That did not last long enough. Bummer. Okay, I guess we'll have to do this the hard way. So, goodbye. There's a lot of different ways to get started. We're going to look at something called Spring Boot. There's a lot of different ways to get started. Of course, my favorite way is to go to start.spring.io, make it your homepage, bookmark it. I find it's therapeutic to check it in the mornings when I'm bored, you know. You can do whatever you want. There's also, of course, for a crowd as awesome as this, there is, of course, a curl-friendly alternative. So I can say curl start.spring.io, and that'll give you a here we are, menu, whoops. There you go. It'll give you the options, same thing as before, but from the command line, so you can actually make a new project using these curl commands, okay? So that's convenient. There's also a CLI, right? It's called the Spring Boot CLI. So the Spring Boot CLI is very, very nice because you can run and write very, very convenient little scripts. So I'm going to write a little script here just to demonstrate an example. This is one way to go. You don't have to use it. You can use anything you want, but it'll demonstrate some interesting principles before we get too far into this. So I'm going to build a REST controller. You can tell it's a REST controller because it says, well, it says greetings REST controller, right? It's going to return a little bit of data when somebody accesses it at localhost 8080/hi/name, okay? So I'm going to say greeting, hello, name, good. At request mapping, alrighty. And there we go. So that's my REST controller. Now, what I want to do is I want to run this, and of course I can do that like this. I can say spring run hi.groovy. And again, I'm using the Groovy language here. We're going to be talking about Java for the balance of this talk, but it's important to remember that that's an option. So I'll say docs pl, right? There's my simple REST service. Now, that is a very trivial example, but I want to point something out here. This is a very important metric in computer science. I think we can all agree that one of the most important definitions of technology's success is, can you tweet it? Now, of course we can, of course, right? So I'm going to go ahead and remove some space here, and there we go. So that's a tweetable REST service. Now, can you do that? Can you? No? Okay, well, yeah. So I don't know I don't know of anything in the JVM that is this productive, and I certainly don't know anything else outside the JVM, so I think this is pretty compelling. Some of you may be looking at my example here, my little thing, and they're saying, oh, well, I don't want to run a Groovy script like that. I want something I can deploy naturally. So I'm going to say spring jar, hi.jar, and that'll give me a jar. I can just do this. I can say java-jar, hi.jar, and hit enter. Now, that's really convenient because I can send that jar via Gmail to my grandpa, and he's got applets, and he can run that. So if your operations team says, oh, we can't run it, tell them Josh's grandpa can do it. Okay? Now, this is a big part of my personal philosophy of make jar, not war. Okay? We'll see that over and over today. Good. Moving on. So, Twitter, here we go. So we're going to go back to here. This is the Java way to go. And you're basically going shopping. This is your chance to go shopping and build something interesting. So I'm going to go here. I'm going to say, I'm going to build a reservation service, okay, like this. I'll say demo, and I'll say artifact as reservation service. I have choices. I can choose Maven or Gradle. How many of you are using Maven? Maven, okay. How many of you are using Gradle? Okay, and now this is where we get sad, so don't freak out. How many of you are using Ant? You're among friends. You're among friends. There's no judgment here. Open source hugs. No? Okay. Well, good. Choose Maven or Gradle. It is an option. You have two choices here, jar or war. If by some fluke of physics, by some strange anomaly, you are stuck in 2001, in the past, the distant past, then you should choose war. But as I think most of us are here today in 2015, in fact, right here, right now, we're going to choose jar because it's the future today, not the past, yesterday, okay? So if you're in the past, choose war. If you're today, choose jar. Again, what's the motto? Make jar, not war, okay? You have options. Okay, Java 1.6, 1.7, 1.8. I'm going to choose 1.8 because it's legitimately amazing. I love Java 8. Java or Groovy, I'll choose Java because fine. I'm going to show you some of the new stuff in Spring Boot 1.3.m1. So that's cool. And what you'll see is that as I choose different versions, you get new options. So I'm going to go shopping. I'm going to say, yes, I would like to use cache. I would like to use the dev tools. I'd like to use Spring Boot support for web. And I'll even bring in Jersey support. I'll bring in Vaadin and REST support. I'm going to bring in JPA because I make bad life decisions. Okay? I'm going to bring in H2. I'm going to bring in Actuator, Remote Shell. Good stuff. Here we go. We've got 50 minutes. What can we do with that? Show and Finder, Command C, Command V. Here we go. Open this up. Oh my. Open this up. And I'm going to load this up in my IDE. Show of hands. How many of you are using Eclipse? Eclipse? Okay. IntelliJ? Right on. What about, is that one guy that always follows me around using NetBeans? Is he here? Are you here? He's always there, and I don't know how he finds me in every country. Okay, well, it works just fine. It's a regular Maven build, so works in any country or any IDE you want to use. I'm going to make the font a little bigger. Font. There we go. Wait for it. Bigger. Okay. Can you read that? I can read it. That's a start. Good. So this is a regular Maven build. You have a starter parent, okay? And the parent is optional, but it is darned convenient. You don't really, I would use it if you can. What it does is it level sets all these different versions of different ecosystem projects. So you can integrate all these pieces and not worry about conflicting version ranges. They just work well together. There are people on the team who have pulled out all their hair, making sure that this stuff all works. You don't have to play whack-a-mole with, Hibernate and, logging libraries and all this stuff. All of these common third-party libraries are level set. We don't bring everything in, but we do, we create a dependency management section for you, okay? Then you have dependencies, and each one of these dependencies corresponds, they map to the checkboxes that we chose on start.spring.io. So I chose a lot of different things. We're going to bring back all of these things as we move forward, but I'm going to comment them out for now, okay? So goodbye. And I'm going to bring in just the Spring Boot starter data JPA jar. This jar doesn't actually, this dependency has no code. It is just a Maven POM that brings in other Maven dependencies, right? It has no code in of itself. It doesn't have any code in the source main, Java package, right? It's just a convenient way to bring in everything I need to be productive with JPA right now. So it's going to bring in the latest and greatest Hibernate, because that's what most people use. It's going to bring in JPA 2, because that's latest and greatest. It's going to bring in all the Spring support for transactions. It's even going to bring in Spring Data JPA. So we're going to start with that. I'm going to go over here to the code. And the code is fairly uninteresting. We have a public static void main class. We'll come back to that in a second. We have an application.properties text file and an empty static directory and an empty templates directory, okay? So both of those are empty. And you have a simple unit test, an empty unit test. And otherwise, that's it, right? So the code generation that we did on start.spring.io was just a convenience. You didn't need it. You could have done it by hand, and it would have been just fine, okay? So now what I'm going to do is I'm going to build an entity of type reservation, something that I can store reservations for like a restaurant, okay? So I'm going to say reservation, and I'm going to annotate this because I'm going to build my domain model. It's going to be like @entity, great, and I'll say private long ID, and I'll say private string reservation name. And again, this is going to be a JPA entity, so I want to just have it automatically generate primary key. I'm going to use H2, so my database is embedded in memory for now. And this is Java, of course, so I have to add some noise. Here we go. More Java. Good. Good. ToString, naturally. Okay, good. So that's fine, right? That's, we know what to do here. This constructor, of course, is for JPA, right? So we'll leave that there. I want to have some way to interact with my database, so I'm going to create a repository. Now, a repository, if you know about domain-driven design, is it's an idiom. It's a way of defining code that speaks to the backing data store, right? I don't want to have SQL code littered about my business logic, so I want to have a repository. But if you think about what most repository code looks like, all of it is just basically, find by ID and create and read and update and delete. It's all kind of boilerplate. It's stuff you don't want to write anyway. And most of the time, the big benefit of the repository is that it's an interface, which you can then unit test, you can mock, right? And so, since you can close your eyes and you can see what the code is supposed to do, let's just let the machine do it. The machine can do a better job anyway, right? So I'm going to say reservation repository. It's an interface. I'm going to be using Spring Data JPA, so I'm going to say extends JPA repository, okay? It's going to manage entities of type reservation whose primary key is long. And I can even, if I go up here, you'll see I have convenient finder methods like find all given a reservation of type T, find all and do sorting, find all given IDs, and save and delete and flush and delete and batch and get one, etc., right? If you want to learn more about repositories and Spring Data, please check out my colleague's Thomas Deramount. He's going to be talking about this stuff later this week, or maybe even today, I don't know. It's going to be awesome. It extends other interfaces that have more generic functionality, and eventually you get to crud repository, which has create, read, update, and delete kind of functionality. And the benefit of this is that depending on the technology that you're using, you get appropriate support, right? It's just all automatically provided for you. If I was using Spring Data Mongo, I would have gotten Mongo repository, right? Instead of this, or Cassandra, or JPA, or Elasticsearch, or React, or Couchbase, or whatever, okay? I can also provide finder methods. I can say, give me all the reservations where the reservation name property equals string rn, right? This is a convention method. It's going to be implemented by convention based on the name of the method. Pretty cool. So now, I've got an interface. I'm going to go ahead and build a bean to actually use that reservation repository and add some data to my database, okay? Now, again, recall that I've set up, oh, there's my friend. Hey, buddy. I'm going to create a bean of type command line. Oh, yeah, right on. Good stuff. Thanks. So I'm going to create a bean of type command line runner, and the command line runner is just an object that will get started when Spring Boot starts up, okay? It's a very simple callback interface. Spring will look at the bean, it'll see that it's got a run method, and it's going to call it, and it's going to pass in public static void main string args, the same string array you see here, the periodic arguments. Oh yeah. Cool. So this is, of course, just a callback interface. It's like initializing bean or disposable bean. Spring is going to see this bean because it says @bean. We're telling Spring that this object is to be managed as an object in the container, and the return value is the object, and then the ID, if you care, which we don't most of the time, is the ID that you infer from the name of the method or from what you put in here. You say, like that, right? So name, blah, blah, blah. I don't care about that. What I'm saying is Spring, in order to create that bean, I need a reference to this repository that we just created. I'm going to inject the type. But since you're looking at this code and you're realizing that this is just an interface with one method, and we just talked about how much I love Java 8, so naturally this is a nice fit for lambdas. Remember, lambdas are going to, how many of you have used lambdas? Oh, they're so good, my friends. You should try them. What it's going to do is it's going to map this interface to an object, this lambda, the syntax here. So it's actually going to take away all this noise that surrounds it, because I don't need the object. I just really need this method body right here, and I need that to be inside of an object that looks like a command line runner. So I'm going to just remove the noise, and I'll say, okay, great. Arrays dot as list, and what are we going to do here? We're going to say Thomas, Peter, Josh, Jürgen. Oh, my other friend Jürgen's here. Go see his talk. It's going to be awesome too. And Peter too. So here we go. For each n, I'm going to say for each one, save a record in the database, new reservation. Okay, great. And then I'm going to say r.findAll. And I'm going to say for each one that I get back, call the system out print line method. Okay, so I'm going to pass in the record in the collection. I've got a list of reservations here, and I'm calling the Java 8 list for each method, and I'm saying, use this method reference. This is a very cool feature in Java 8. It's very new. I mean, only C, Lisp, Smalltalk, COBOL, C#, C++, Perl, Python, Ruby, Go, Perl, PHP, JavaScript. I mean, only a few languages have this feature, okay? We're winning. We're winning. Now, it's a little embarrassing because even C++, a language whose governing body meets only once every few years, even they got it before we did. So that's cool. Okay, good. So we've got that, and then I'm gonna print out everything that we get from there, and then I'm gonna say find by reservation name, and I'll say call my. I'm gonna find my friend there. I'm gonna say for each record that we get back, we'll see this printed out as well. So we should see Jakob printed out twice, yeah. And then I'm gonna run the application, and there we go. Now it's gonna parse Java. Good. Now what's gonna happen is it's gonna find the embedded H2 database. It's gonna create an H2 database for us, and then it's going to connect our repository to that. So it's already saved the records. And we see there's the first 5 records down here. There's the same record, 1, and then again, right? So of course that worked. We knew that was going to work. Do I look like I make mistakes? Come on. No. Much, much more importantly, what I really wanted to show you was this. Now, this ASCII artwork is a thing of art. It's a thing of beauty. There are 2 people on the Spring team, 2 people with PhDs, doctors, who in previous lives concern themselves with the celestial bodies in the heavens, nuclear physics, rocket scientists, my friends. And it makes me very happy to imagine that one day they have a GitHub issue that said, we need good ASCII artwork, and we need it now. Look at this, it's beautiful. Now, you could change this if you wanted, but I would remind you of this fable of Icarus, who created wings to fly to the sun, and his ego and arrogance brought him low. So yes, of course you could change this ASCII artwork, but really, could you? Should you? Should you? Which reminds me, the folks at IntelliJ, who normally make an amazing product, have the dumbest feature I've ever seen. Why are you here? Who invited you? What is this even for? Don't click that button. Let's do a petition to get rid of that button. Great. Okay, so I've got an application now, and it's correctly talking to the database. They say that an application of sufficient complexity eventually sends email. I'm going to take it a step further. Today, an application of sufficient complexity eventually sprouts a REST API. So what I'm going to do is I'm going to bring in JAX-RS, Jersey support, and I'll bring in Spring Boot's support for Spring MVC, okay? And we're going to implement REST APIs a couple of different ways, okay? Here we go. Here we are. Good. Go to demo application, and now what I'm going to do is I'm going to build a regular, Spring MVC kind of REST controller, reservation REST controller. And I'm doing this everything inside the same class just because I'm kind of, lazy. So do whatever you want. You don't have to do it like this, obviously. I just want to do it and have it all in one place for a demo, okay? Also, don't ever do this. Not even when you're by yourself, all alone at home, and nobody's looking. Don't ever do this. See, every time you use field injection, a unit test dies. Now, you need to use setter injection, okay? It's much better. So here we go, reservations, and I'll say collection of reservation, and I'll say, reservations, great, and I want to return this dot reservation repository dot find all, great, fabulous, and then I also want to do the same thing using JAX-RS. So what I'll do is I'll say at named. Okay, and then I'm going to say public static class, reservation, endpoint, and then I'll say at get, and I'll say produces, and I'll say application media, media type, dots application, come on, be good, media type. Nope. Why would you even do that? It's like the least helpful thing you could do. Okay. Naturally, do it. Whatever. Application, JSON value, fair enough. And then I'll say collection of Reservation, great, reservations, who cares, great, fabulous. Then I'll say return, and I'm going to do @inject because I can, why not? Both are natively supported by Spring, of course. Then I'll say reservation repository.findAll, same thing. And let's see what else. Is that going to work? That should be fine, right? Am I missing anything? Oh, path, right? So I'm going to say @path, and I'll say reservations as well. And I don't want these to conflict, right? I'm going to have two of them mapped to the same endpoint. So I'm going to set up my JSON support, and I'm going to also make it so that this doesn't conflict with each other. So I'm going to say resource config, great, fabulous, like so. And I'll say Jersey config, great. And I'm going to say register Jersey. I'm going to say register Jackson feature dot class, and then I'll say register reservation endpoint dot class. Good, and then I'll go up here and I'll say application path is Jersey, just to be very specific. And I'll also make this component so that it gets picked up, okay? There we go. So now we have the JAX-RS support and the equivalent Spring MVC one. Let's go ahead and run this and see what's happening, see how it works. Good stuff so far. Up, and away. Oh, man, it's kind of warm up here. Kind of warm, good stuff. Localhost, so I'll go down here, and there's my Spring MVC endpoint, of course, that's what we expected, of course that's going to work. Jersey as well should be fine, right? Or not, that's an option. What did I do wrong? Reservations, produces, collection, always worth cheating. This is why it's good to have notes, my friend. Atom, desktop, old. Let's make sure we do this correctly, because I'm not in the mood of worrying about it. So Command P, demo, application, or not. There we go. Good. Do you see anything different here, my friend? Static class. I just want to make sure we're on the same page. Jersey config, great. Extends resource config, inject, path, reservations, produces. Well, that doesn't make any sense. Let's try again. Get produces, right? Literally this. It's the same code. Copy and paste. Copy and paste. Don't do that at home. Yeah, I don't know. Never know. Reservation repository, that's fine. Repo. Repository, great. Find all. Fabulous. Get produces. Here we go. Public static class, Jersey config, registry. Looks legit to me. Who knows? Okay. There we go. Yay. A round of applause is appropriate there, friends. Thank you. Thank you. Okay. Good. So we can see that they are functionally equivalent. Not all that bad in terms of the code footprint. My brain left me here all alone right when I needed it, so that's not great. But, oh, maybe it's because I didn't make it public. Oh, that's not good. Okay. Anyway, they work, right? Of course, this is functionally equivalent, but if I'm honest, just between you and me, I didn't really need this. This is actually way more work than you need to do, because all I really want to do is expose the entities in my repository to HTTP. This is what REST is all about, right? Mapping the state transitions of my business entities from HTTP to my repository, which already knows how to do creation, reading, updating, deleting. So what I'm going to do is I'm going to go back to my Maven build here, and I'm going to bring in Spring Boot Starter Data REST, like so. Okay, and then I'll restart. Okay, here we go, demo application, stop and rerun, naturally. And what that's going to do is it's going to start up my application with Spring Data REST on the class path, and that's going to find this repository, which already knows how to do creation, reading, updating, and deleting. And now when I revisit reservations, you'll see I've got the same API, except it's better, right? So this is actually hypermedia. This is an implementation of hypertext as the engine of application state, HotOS. This is a design pattern designed to promote resilient, self-describing REST services. The idea is that every REST response should have information enough to be able to further manipulate that REST resource without any advanced or a priori knowledge, okay? So that's a very, very good pattern to have if you're building long-lived services. And of course, we get a lot of other stuff for free, so I can deep link, I can send, delete, and post, and update, and all that stuff, and all this just works. Great. Now, this wouldn't be much of a demo if I didn't have a regular server-side MVC kind of thing, so I'm gonna go back over here and I'll say at controller, public static class reservation MVC controller. And all this is going to do is it's going to respond to REST requests at some URL that I would never use in production ever, something that would be insane, just so that you know that this is a joke, right? I would never use this. There's no correlation here between the URL and what's happening in the code. So I'm going to choose reservations.php. Now, again, you have options. Do whatever you want, right? So I'm going to say model. Okay, there we go. I'm going to say model.add attribute. Great, reservations. And what I'm going to do is I'm going to import, I'm going to inject my repository, private reservation repository. Great. And I'll say this.reservation.repository.findAll. Fabulous. And then I'm going to return a string, and that string is going to be used to resolve a view template. Now, the view template is any kind of template you want. There's lots of different options. For our purposes, we're going to go ahead and use timeleaf. Now, timeleaf is one of many different choices for building templates that are natural. You can preview them in the browser, right? How many of you have ever had that experience where you take a JSP page and then you give it to the graphics designer, and then the graphics designer tries to set your house aflame, or they leave a bag of poop on fire in front of your door? You know that thing I'm talking about? You know that when they look at you like they want to hurt you, and they really do? Yeah, that's JSP. So again, they hate it when you do that because they can't preview it, right? It doesn't look right in the browser. So natural templating is much more useful here. So I'm going to say, bring in my little template here, reservations.html. Great. Terminal, cat. I'm going to cheat again. Don't do this at home. .html, great. PB copy. Paste, and this is just a regular, I'm not a designer, but the idea is basic. Server-side generated HTML for every R on the collection of reservations coming from the model, render this HTML block, and then dereference the ID and the reservation name. Great. Let's run this stuff again. Here we go. Stop and rerun. I'm going to say, don't ask me again. Thank you. And what that's going to do is it's going to find the template. It's going to find the path, and it's going to plug in a view resolver, and that view resolver is a default, but you can change it. By default, it's going to look in source, main, resources, templates, and then suffix it. It's going to do that, blah, and then .html. So if I go to reservations.php, there's my very simple template. Now you can use Groovy server pages, you can use Velocity or FreeMarker or Mustache or Timeleaf or even JSP if you hurt yourself, but don't. You can find things on the sidewalk that will do a better job. Okay, just avoid. I believe in you. Good. So now we have REST endpoint, we have a Jersey endpoint, we have a reservations.php page. I wanted to show you that one of the nice things about Spring Boot is it makes it very easy to tie in all these great ecosystem projects, right? These things that are not necessarily part of Spring, but that it's very easy to configure, right? And so one of the things that we've added support for recently, there are a lot of different other projects and more of them on the way, but one of them that's actually very recent is Vaadin, right? So again, this is not ours, we don't care. I mean, use whatever you want. This happens to be very nice for a certain use case. I'm sure there are some friendly people right outside the door who'll tell you more. But what I wanted to show you is that just by bringing in this dependency, which I'm going to do right here, Spring Boot, this is the Vaadin Spring Boot, Spring Boot starter. We're going to add support for using Vaadin from our app. And the result will be that it's actually simpler to use Vaadin from Spring Boot than it is to use it directly, right? Because we actually take all the pain away. So we're going to say @theme is Valo, okay? And we're going to say public static class reservation UI extends UI, and then I'll say @enter, okay, theme, and I'm going to create a constructor, and in constructor I'll say that this needs to be named what? What is this, path? Yep. And then in the constructor, I need to do what? Oh, I need to do init, right? So that's the method. Command init, command I, init, and then what I'm going to do is I'm going to set up some components just a table just to display some data, okay? Same as we've done thus far. I'm going to bring in the Vaadin table component here. And then I'm going to pass in, I'm going to inject my repository just as before. Here we go. And I'm going to say table.setContainerDataSource, and that's going to look for a container of some sort. I'm going to say new bean item container of type reservation, passing in the class literal for my entity, great, and then passing in the data from our data store, okay? Just as before. Then I'll say set size is full, and then I'll say set content equals to table, and that should be enough. Again, this is this build on GWT, so what you're actually getting is server-side business logic, but on the client, it all gets transpiled to very, very fast JavaScript that runs super, super quick on the client. And there are many other open source projects and third-party projects, like, for example, Activity, which I mentioned earlier. Stormpath, which is an identity provider as a service, they have something as well. Ratpack is a very nice example as well. So this is my, it's not particularly great, but you can click and sort, and it's all very, very dynamic. And this is all just happening because we added the right dependency. And again, this is, as you can see, GWT, right? That's actually it's just one thing you can do. There are a lot of other examples, but the point is to demonstrate this is all very easy to stand up. Great, so now we have a Vaadin UI, we have 2 REST endpoints. I'm going to introduce some slow so we can demonstrate a feature here. And what I want to show is that it's very easy with one of the new features inside of Spring Boot 1.3 to turn on Spring Boot's caching abstraction. So I'm going to go back to my code here, and I'm going to say, okay, bring in the cache API here, okay, and I'm going to bring in JSR 107. So if you want to use that, you can. You can also use Spring's older cache SPI, cache manager SPI. That's fine as well. Don't care. Great. Oops, wrong one. Javax.cache. Sorry, muscle reflex. Okay, there we go. And then once that's on the class path, I go back to my code. I'm going to say turn on the caching support. Great. And then I'm going to introduce some slow. And here's what I'm going to do. I'm going to create a service and introduce a timeout so we can see this in action, okay? So I'm going to say class service, like so, public, static, class, reservation, service, great. And I'll say @AutoWired, private reservation repository. And again, this is kind of arbitrary. So what I'm going to do is I'm going to say cache result, public collection of reservation, get reservations, and all this is going to do is call the repository after a 5-second sleep. Okay, so throws exception, and then I'll say return this dot repository dot find all just as before, and then I'm going to use this I'm going to modify my Jersey endpoint so we can serve data and we can see the lag as a result of this change. Okay, so reservation service, here we are. Great. Service, fine. And we'll say service, fair enough, get reservations. Good. So now we should see this take 5 seconds the first time, and then every subsequent time, it'll cache the result and then return the same value. So every time somebody calls get reservations, if there were parameters, those would be used as part of the key, and the return value would be cached. I'm using a concurrent hash map by default, but if I were using Infinispan or EHCast or Hazelcast or any JSR 107 implementation, or any Spring Cache manager implementation, those would get picked up as well. Redis, for example, you just add the right metrics library, and that'll just get picked up for you. So I'm going to restart. Did I already restart? I think I did. Here we go, Jersey reservations. It's going to take 5 seconds. Naturally, we expect it to. Here we go. There's the first time, but now the second time, it's much faster, right? So again, I didn't have to write the code for that. Now, what do we got? We have Jersey, we have a regular REST endpoint, we have Spring Data REST, we have an MVC controller, we have a Vaadin UI. And if this was all I wanted to show you, then I think we could agree this is not bad, right? This is actually a very, very productive way to build apps. So far, so good? Oh. Thank you. But this is not really the end of the story. Again, we at Pivotal care very much about Agile. We care about reducing the time between having an idea, which is a theory, right? It's just a theory, and getting it into your customer's hands. That's when you validate that theory. Every minute you spend deferring the integration of the product with your customers is the minute you defer the validation of your theory. You don't know if your code is going to work until it's in their hands. And so we want to be able to get code into production, into the customer's hands, as quickly as possible. That's very much what Agile and continuous delivery is all about, right? And if you talk about, if we think about what it means to go to production, how many of you have ever read Michael Nygaard's amazing book, Release It? Release It? Anyway? The punchline, the big takeaway is that code complete is not the same as production ready. There's a long distance between finishing your application and getting all the features done, and then actually having it ready for production. And this distance is something that we don't think about at the very beginning. We start planning all these pieces of code, and we start out adding all these cool features. But getting to production is actually a very, very different challenge. And there's a lot of non-functional requirements that may block you from getting to production. Spring Boot aims to make those non-functional requirements as trivial to deal with as possible. So what we're going to do is bring in the Spring Boot starter actuator. Here we go. Okay. And then I'm going to bring in the dev tools, and I'm going to bring in the remote shell. Okay. These are going to set up a few things for us that are mostly concerned with operations, right? Mostly concerned with making it so that your application is production ready out of the box. So here we go. We're going to restart, having added those dependencies. I'll drink some water because I can. Here we go. Localhost. I'm going to go back to the Jersey reservations endpoint in a second here. That's going to take 5 seconds. I'll go to UI. I'll go to localhost, regular reservations. There we go. So all these endpoints are now coming up. I'm going to hit refresh a lot, right? I'm making a lot of requests on these endpoints. Refresh, refresh, refresh. And as I do that, I'm creating traffic, and I can see information about that traffic by going to /metrics, okay? This is an endpoint that exposes information about the state of the application. So I can see, for example, that I have made 2 requests, no, sorry, wrong one. I have made 22 requests to Jersey /reservations, and I got a status code of 200. I made 9 requests to /UI, and I got a status code of 200. If I want to see which requests I made, I can go to /trace, okay? So trace is an endpoint that shows me the requests that I made into the application, the request and response headers and all that stuff, the time, the HTTP verbs. If I want to see which endpoints, and this is very important for auditability, excuse me, if I want to see which endpoints were exposed by a Spring MVC, I can go to the mappings endpoint. This shows me that reservations.php was exposed by java.lang.string demo.demo application, blah, blah, blah. I can see that, error produces text HTML. I can see that mappings requires an HTTP verb of get, right? So I can get information about the application itself. I can go to env, and I can see the system.get properties, all the information about my application. But notice, however, I can also see my system.get env, and very, very conveniently, passwords and secrets are blanked out, right? So this is all hidden away. If I go to beans, I can get an enumeration of all the beans as they're wired together and their dependencies, so I can see which objects depend on which, and which objects have been created by Spring Boot. Right? I get a lot of different things. One of the most interesting health endpoints is the health endpoint. Unfortunately, this endpoint isn't very useful right now. I want to see more information. So what we're going to do is we're going to customize how Spring Boot is working. Okay? So we're going to go back to here, application.properties, and we're going to say server.port. First of all, I want the application to listen on port 8000. I want the management endpoints, the metrics, the admin, all that stuff. I want that to be on 9000. I want management endpoints to also be under a separate path, so /admin. And then I'm going to say endpoints health enabled is true. And then I'm going to say endpoints.health sensitive is false. Okay? And then I'm going to go back to my code, and I'm going to override what is shown in the health indicator, right? The health endpoint. So I'm going to say @bean health indicator. And I'm going to create a new object of type health indicator. But again, look that by default, there's already plenty of good ones on the class path that will be automatically set up for you. So for example, your data source, your disk space, JMS, Java Mail, Mongo, RabbitMQ, Redis, Solr, Elasticsearch, etc., are all going to be set up for you if those are on the class path. So we're just going to contribute our own definition to a long list of definitions that are already there for you. So I'm going to say, okay, and then do build, and then I'll go back here. And again, this is a perfect candidate for a Java 8 Lambda, so get rid of all this. I'm going to get rid of all this as well, and I'll say, like that, okay? And there you go. So I'm going to just add my own health indicator, and I'm going to restart the application. What that'll do is it'll find all the health indicators that are on the class path, and then, render the output. Now, again, there's other options here. I could have said out of service, or I could have said up, or whatever, but, I'm going to just build. And then I'm going to go back to my endpoint here and refresh, and you'll see that the endpoint is no longer working. It's on port 8080, after all. We changed the port. So now I have to go to port 9000, /admin, go to /health, and there you can see, not only did the sensitive stuff that was previously hidden, like the disk space and the database information, get shown, but my custom health indicator is now there as well. Okay? So again, very, very, very powerful ways to configure things. I can go to port 8000, and I can see the actual application. Here's /reservations, here's reservations.1, etc. So again, these are non-functional requirements, but they are very important to get right when you're building an application. Now, this is just one way to look at the application. These metrics that we're showing right now, these are all things that get collected for you by default, and they get plugged into a metrics registry. And that is an interface, and you can override all of these different endpoints. You can add, you can change where they get written to, you can set up all sorts of stuff. So what I'm going to do is I'm going to, first of all, contribute a bean that changes one of the places that these metrics get written to. Instead of just in memory, I also want them to get written to a JMX endpoint. So I'm going to say metrics, at export metric writer. I'm going to say metric writer, and this is a new feature. I'm going to use JMX here, but if you're using OpenTSDB or StatsD or drop wizard metrics, all of that stuff will work as well. Okay, so I'm going to say at qualifier. Either one is fine in this case. I'm going to say mbean exporter, and I'll say give me the mbean exporter with that ID. There's two of them. I'm going to say return new JMX metrics writer, and I'm going to pass in the exporter. Now, I only want this code, for example, to work when it's in a JMS environment. So I'm going to say spring.jmx.enabled. Okay, so as long as that's true, then this will get run. Good. So now if I run that code again, it's going to actually write these metrics to JMX, or I can actually graph them and visualize them very conveniently. I can see traffic. But again, if you're using OpenTSDB or Graphite or any of these other things, it's very easy to plug that in as well. So now, if I go to JConsole, I'm going to make some requests here, / request, lots of requests. If I go to JConsole here, I'll go to demo application, hit connect, insecure, great, fabulous. And I've got org Spring Framework boot, endpoint, and of course you can see all the stuff that we had before, operations, get data, all that stuff is here. But more importantly, and I think I connected to the wrong one, connection, sorry? That was cool. What happened? What? Sorry? Oh, right. Okay, well, fair enough. PED. Thank you. Jeez. Okay, that was actually it. Yeah, okay. Insecure connection and beans, blah, blah, blah. Did I? Sad. Thank you for that. So we'll go back here and we'll say spring.jmx.enabled is true. Great. And I'll restart. And what that'll do is it'll actually turn on the feature. Now, I may not want this in all places, so we'll see later that I can actually override these properties. Here we go. Close this. Terminal, JConsole, voila. Go back to my endpoint, refresh. Great. Go down to here. I'm going to say, okay, launch insecure connection, fabulous, mbeans. There we go. Now we're cooking. So now I've got the metrics endpoint that we had before, as well as the JMX endpoint specifically. And here I can see the information about what we did, as well as the actual values. So here we go. Status, reservations, /1, gauge, response, attributes. There we go. So this is a attribute that reflects how many requests I've made into this endpoint. I'm going to go here and hit refresh a few times. //. And as I do that, you can see the graph is moving in time to reflect what's happening. And of course, it'll, oh, that's the wrong, is that the wrong attribute? Sorry? Response time gauge. Attributes. Value. There it is. So now you can see the actual graph moving in a moving average of all the information there. So that's very, very useful. There's more stuff coming, of course, StatsD and OpenTSDB, that's already there in code. This application, I'm going to go ahead and remove this so it doesn't cause us any trouble, you danger. This application is a Maven jar. Remember what we talked about? Make jar, not war. Okay. It's a Maven build. It's a so-called fat jar. And I'm going to add a new feature that I love inside of Spring Boot 1.3. It's going to be called executable true. Here we go. I'm going to go to the command line. Okay. And I'm going to say reservation service, Maven clean install. Here we go. And that's going to compile my code, create the fat jar, run the test, blah, blah, blah. Oh, whoops. Hold on. I want to go faster. Skip tests. It's going to start up all that stuff for a second. There we go. CD target. Now, here's my jar. Of course, you already know, if you've been following Spring Boot, that I can do Java -jar, blah, blah, blah. Java -jar demo or reservation service. That works, of course. And I can also override things. I can say -d server.port equals 8010, for example, right? That's fine. I can also do export server underscore port equals 8020, and then do Java -jar. And then run the application like this, right? Of course that's going to work. We knew that was going to work. This is kind of an old feature, but I think it's really worth mentioning. This is dead simple to deploy, right? Again, think of my grandpa. Now, a lot of people use containers. They use application servers. How many of you deploy one application to one container? Like one app to one Tomcat? Yeah? Okay. It's most application production deployments I've seen have one app and then they have one Tomcat, and they actually check in the configuration for that specific application from server.xml in the code for that application. There are these concerns that they can only configure in the container, but they belong to the application, and so they don't want to keep these things separate. In fact, I've seen some horrifying things where people actually check in Tomcat itself into their code, right? If these concerns are application concerns, then they should live with your application. So having Spring Boot manage all this stuff, and oh, by the way, that was port 8020, right? That's what I want to show you there. Having all these things in one place is very convenient, and being able to just manage the application just by doing start the jar is even nicer. However, in Spring Boot 1.3, we've got a new feature called executable jars, which, that was, yeah. So in case you missed what just happened here, sorcery and witchcraft. Yep, I just did this. Can you do that? Nope. What is happening is that did you know that Java jars are loaded from the end of the file backwards? So you can actually put a script at the beginning of the file and then execute it, right? So I'm going to say cat reservation less. There's my script. Good, calming ASCII artwork, okay, right? And there's and if you keep going, you'll see all this is here as well, right? So that's all there. I'm going to we're going to run the application one more time, and I'll show you a few more places where you can actually see what this application is doing. While I'm doing that, I wanted to point out that this is all happening thanks to the magic of spring.factories, right? This is a text file that lives in the meta-inf directory of each Spring Boot application. And you can use the same thing in your own code. You can say spring.factories and then have an attribute, org spring framework boot autoconfigure, enable autoconfiguration equals, and then you have all these Java config classes. So I'm going to open up rabbit autoconfig, and I can see it's just a Java config class that has conditions that say, okay, only load this class if these conditions are true. For example, if this type is on the class path, or if this property is set to a certain value. So you can do this in your own jars. If you have security or PMI or Sarbanes-Oxley compliance or something like that, put the code in one jar, add it to the class path of your Spring Boot app, and things will just dynamically get registered for you. That's how, as we've been talking, I've been adding new jars, and voila, magic, new stuff is on the class path, and it just works. Now that I've got this, I'm going to show you a few other ways to look at that information, things that I love. First of all, of course, we saw JConsole. I also added the remote shell, okay? So this is one of my other favorite features. By default, absent any specific Spring security configuration, it's going to give me a username and password. Here's the password. And I'm going to say SSH-P 2000 user at 127.0.0.1 and go. So that's going to give me very calming, very soothing ASCII artwork. Now, if you're in a production crisis, this is what you want, right? Once you're in, you can ask for help. You can do whatever you want, right? I can type in help, great. I can say system prop ls, great. I can say metrics, fabulous. And this is all live. I'm seeing the numbers update by themselves. My favorite view, of course, is the dashboard, which looks like this. So this is actually showing you the metaspace there and the compressed class space and all that. If you're using Java 1.8, you get metaspace. If you're using 1.6 or 7, you get permgen, etc. So what have we covered? I think we've covered a fair amount here. We've covered how to build a simple Spring Boot application, how to add support for third-party projects, not the least of which are Hibernate and JaxRS, and we saw the JSR 107 and the cache abstraction. We saw Spring MVC. We saw how easy it was to get a jar, not a war, although you can get a war if you want, again, for those of you stuck in the distant past. We've added non-functional requirements that you can use to make the operations people happy about deploying your application. We saw how easy it was to customize things through auto-configuration and dependency injection. And then we saw how easy it was to customize things using properties, right? We saw how to override those properties. And we saw how easy it was to manage one of these applications. Again, actually, the thing to remember about this executable jar that I created here is that if I actually go to Spring Boot 1.3, reference guide, this executable jar is ready for initd. Here we go. This executable jar is also automatically ready for example, to be registered with initd. So if you do sudo link s, var myappjar, etc. initd.myapp, it'll automatically respond to initd start, stop, restart commands. Same thing for systemd, right? So if you do systemd services, this jar and the script that we create for you automatically knows how to respond to those. So it makes it dead simple to create production-ready applications to get out the door very quickly. I'm going to be giving another talk in some, right after the quickie here. Come to that talk. We're going to talk about how to build distributed systems using something called Spring Cloud that builds on top of this. If Spring Boot is an easy way to get an application up and running, to get a service up and running, the inclination today is to build applications that live on the cloud, to be able to scale them out horizontally, to break apart the functionality into small, singly focused services. Doing so creates friction. It creates a fragility that makes it hard to manage complexity. But Spring Cloud provides integration for design patterns and support for common microservice middleware to support building resilient systems that build on top of Netflix, that build on top of middleware like Zookeeper and Console and so on. So I hope you'll join me for that. I am here for questions. Guys, dziękuję. Thank you so much. You guys are amazing. Do me a favor. If you like, did you guys like it? Yeah. Okay. Would you use it? Yeah. Okay. Do me a favor. Vote about it. Would you tell them that I can come back? So vodka. Come on. Thank you.